All right, so this is the absent video for energy densities of organic fuels. So I'm going to go ahead and read out the intro paragraph. How much energy is released when an object burns? One way to determine this is to measure the heat flow from the object to its surroundings. If heat flows from the object to its surroundings, then the temperature of the surroundings will increase. This activity will introduce the concept of calorimetry and investigate the energy content of organic fuels. So we're going to do the energy content of an organic fuel being a Cheeto. The lab says charcoal, but know that we are using a Cheeto for this, okay? And let's kind of like relate this back to our investigative phenomenon of wildfires. So remember, wildfires require the fuel or the fire triangle. That is fuel and oxygen with energy is what keeps our wildfires burning. So if we could relate this to that, our Cheeto in this case is the fuel. And remember that there's chemical potential energy stored in the bonds of this Cheeto, okay? And we have oxygen that's going to react within the air. And essentially, we're going to add energy to the system by lighting the Cheeto on fire. Yay, okay? So in order to kind of quantify this, there's some data we need to take, okay? We're going to start with the mass of the Cheeto. Okay, so let's take the mass of the Cheeto. So we're going to take the mass of the Cheeto. It's 0.9 grams, okay? So we're going to start off with 0.9 grams of our Cheeto. I'm going to put this in the data table. The student had started writing on this. So 0.9 grams of our Cheeto. All right. And we also need, well, let me get to that in a second, okay? Then it asks you to put 50 milliliters of water in our calorimeter, which I've already done. And also, before doing this lab activity, you're supposed to read the lab background. So if you haven't already read the lab background, go ahead and pause this video, go read the lab background, and make sure that you've taken notes on the vocab for that. There's 5 terms that I wanted you to define from that lab background. And if you've paused the video and you're back, let's get going. So essentially, what we're trying to do is we're trying to quantify how much energy is going to burn in this Cheeto. So we'll light it on fire. And we're trying to assume that the energy, for the most part, is going up to what we call our calorimeter. Now, a calorimeter is just a device we use to quantify temperature change. So we're going to be taking the temperature of the water in this can and seeing what temperature it rises to. And that rise in temperature is going to directly relate to how much energy was in the Cheeto. And we'll do some math with that with our analysis questions, okay? So we've added 50 milliliters of water. Let's go ahead and take our initial temperature. Remember, when we're taking temperature, we don't want to touch the sides. We're right there at around, let me turn this a little bit more so you can see. Right there, I'd say we're at about 25 degrees. All right, so we're at 25 degrees Celsius as our initial temperature. Essentially, I'm going to light my Cheeto and let it burn and see how much energy we produce. So let's get this Cheeto going. Takes a minute sometimes to get it going. And we're just going to allow it to burn until it stops. I'm going to try to adjust this so it's a little bit more underneath the can. And really, I should have this temperature. And there, I'm trying to find the maximum temperature it's going to go to. All right, so it's done burning. I'm gonna look at my temperature, see if it's still going up. Looks like we're right about 30 degrees right now. So yeah, let's call it 30, like that's right in the middle of 30 and 31, so we're gonna call it 30.5. All right. And then I'm gonna need my final mass of my Cheeto, so let's go ahead, let's take it over to our scale. 0.8. So we sorry guys. So we transformed 0.1 grams. All right, 0.8 grams. So let's look at these analysis questions, okay? So it says, determine the change in temperature of the water by subtracting the initial water from the final water. Okay, so we wanna see that difference. We're gonna take, you're gonna take your final and you're gonna subtract your initial. Okay, so I've given you the data. You're gonna go ahead and get your answer for number 1 in degrees Celsius, right? Because that is our unit for temperature. Number 2, calculate the heat gained by the water when the charcoal burned. Okay, so in the lab background, it gives you this equation, Q equals mc delta T. Okay, in this equation, M stands for mass, C stands for what we call specific heat, and delta T stands for temperature change. And then, of course, Q is energy or heat. Okay, so we're trying to find the heat, the energy gained by the water. So essentially what I have to do is I have to find my mass, but I have to find the mass of the thing that's changing temperature. Remember that we're looking at how the water changed temperature, so we need the mass of our water. Now, the only thing we used of the water was 50 milliliters, so I want to show you guys. 50 milliliters of water. Well, the density of water is 1 gram per 1 milliliter. It's 1 gram per milliliter. So essentially 50 milliliters of water is also 50 grams of water. Okay, milliliters cancel, we get left in grams. So where are we at? So we have our mass, which is 50 grams. That's a 5, you guys. Okay. Then we have our C, our specific heat. Now, specific heat is just a constant. It's a number that's going to be given to you. I like you guys to actually memorize water specific heat, but it's 4.18. The unit of joules, which is our unit for energy, per gram Celsius. Now, the reason why this is our unit is because our definition of specific heat is the energy required. So how much energy is required to increase the temperature of 1 gram of something 1 degree Celsius. So for water, we need 4.18 joules to increase 1 gram of water 1 degree Celsius. So that's where we get this number from. And then lastly, we have our temperature change, which you already calculated up here. Okay, so you're going to put basically your answer to number 1 in degrees Celsius here. So you should be doing 50 times 4.18 times your answer to number 1, which you solve for here. And that's going to give you your answer in the unit of, if we look, our grams, see grams cancel, Celsius cancels. We should end up in our unit of joules. Okay, it's going to be a decent sized number. All right. Number 3, determine how much of the charcoal burned, aka the Cheeto, by subtracting the final mass of the charcoal from the initial mass. So you're going to take your final mass and you're going to subtract it from your initial. So here's our initial mass minus final mass. And you're going to get your answer in grams, right? Because you found your answer in grams. Number 4, calculate the energy content per gram of charcoal. So it's like energy per gram. Okay, so what you're going to do is you're going to take your answer to number 2 because that was your energy. So you're going to take your answer to number 2. You're going to divide that by your answer to number 3 because that was your energy per gram. And that's going to give you your answer to number 4. This question. Now, the unit, because our unit for 2 was joules, and our unit for 3 was grams, well, joules divided by grams, our unit needs to be joules divided by grams. Number 5, discuss some of the sources of experimental error. So I'm going to do what I did in class, you guys. I'm going to just kind of talk about, again, our lab, what we saw. So we have, it's not hangman, you guys. I think I was trying to draw the thermometer. Oh gosh, you guys, thermometer. And then we have our soda can calorimeter. It's got some water in there. Remember, we got 50 milliliters of water in there. We got our Cheeto. Here he is. Cheeto. And let's talk about like what happened in this lab. So a couple things that could be sources of error. One, I mean, essentially we have to use the lighter to heat this up. And so technically like some of the lighter fluid is being, is fuel as well. So there could be like some of the heat not actually coming from the calories of the Cheeto, but just the calories that are in this, right? Because we have to start our experiment. So that's one source of error. 2, once our Cheeto gets is lighting and is burning, we're making the assumption that most of the energy is going up, right? We know heat rises, right? Hot things go up. If you think about your house, if you think about a house or a building, the floors above are going to be typically hotter than the floors below because heat rises. So that heat's going up. But also, this is what we call an open system. Okay, so because this system is open, we're losing energy to our surroundings because not only is energy going up, it's going all around, right? Technically, even like some of the energy is going down to the aluminum foil and so forth. So a lot of our energy, our main source of error is that this is an open system, right? Energy is being lost to the surroundings. And so therefore you're not getting the same kind of temperature change here that you would if you had, let's say, a closed system, like what's known as a bomb calorimeter. It's like a closed system and you put a little food item in there and then you go and explode it and then it calculates your temperature change. And that's essentially how they find the calories for different food items. And that's going to relate with our next assignment, you guys, where we're analyzing food labels and looking at calories and those kind of things, okay? But again, experimental errors, it's really for this because you guys didn't do the lab in class. It's going to be the fact that it's an open system. And we could make there's ways we could make our system less open. We could like maybe cover this area with make it more closed off in some kind of way. But again, if it's an open system, you're losing energy to the surroundings. And that should be your answer to number 5. Okay? Let me know if you have questions on Teams.